Hello viewers, this is Wagler now taking you through the tutorial for A-level applied mathematics. And this video, I'm going to go through the topic of motion of connected particles involving inclined planes. So this video is in mechanics and suitable for students in both senior 5 and senior 6 offering principal mathematics. Now these are the very questions I left in the previous video, and I believe by now you have already tried them out and ready to mark yourself and check your progress. So we shall start with question 1. So question 1 came from UNEB 2012 paper 2 question 6, and it says a light inextensible string passes over a smooth pulley fixed at the top of a smooth plane inclined at 30 degrees to the horizontal. A mass of 4 kilograms is attached to one end of the string and hangs freely. Note that word, hangs freely. A mass M is attached to the other end of the string and rests on the inclined plane. If the system is in equilibrium, note that word, equilibrium, find M. So in this case, they have not drawn for us a sketch, but we have to read the question, interpret it well, and draw a sketch. Then we can answer the questions. So the first thing to do is to make a sketch of the force diagram. So they told us that the plane is inclined at 30 degrees to the horizontal. That is why there is this 30. Then one mass is lying on the inclined plane, another one is hanging freely, and then equilibrium. So to show the forces, we begin with weight. So this is mg. This mass is m kilograms, so weight will be mg. Then we shall resolve it into two components. One will be parallel to the plane, which is mg sine theta, sine 30. Another will be perpendicular to the plane, which is mg cos 30 degrees. Then we shall put normal reaction, which is capital R. Then the tension in the string, because this is downwards, this is down the plane, this will be up the plane, and here it will be down the plane. Then here we shall start with the weight, which is 4g, and here to tension here will be upwards. So the tension is the same because the string is the same string is connecting both particles. That's why it is just T throughout. So this is upwards, this here to be downwards. So they told us they are in equilibrium. So now we shall start. We know that for equilibrium, acceleration is 0. And therefore opposite forces are equal. Therefore for the 4 kilogram mass, we are interested in these forces. Therefore this force will be equal to this force. So we shall come and say T is equal to 4g, but we know g is 9.8. Therefore T will be equal to 39.2 newtons. What about for the m kilogram mass? For the m kilogram mass, we are interested in these forces. So forces parallel to the plane, we shall use this. And you realize that T will be equal to mg sine 30 degrees. Therefore, you come and say T is equal to mg sine 30 degrees. And we know G is there, and we know G and T, so we shall substitute for T and for G to remain with M as the only unknown. Therefore, when I simplify, I come up with 39.2 equal to 4.9 M. Therefore, M is equal to 8 kilograms. So basically, that's what they wanted, and now let's see how mass can be awarded. So B1 for the correct force diagram, M1 for resolving and substitution, A1 for the tension, M1 for resolving and substitution, A1 for output, which is the mass they want. So that was question 1. Now question 2 came from UNEB 2013 paper 2 question 10, and it says a mass of 12 kilograms rests on a smooth inclined plane which is 6 meters long and 1 meter high. The mass is connected by a light inaccessible string which passes over a smooth pulley, fixed pulley, at the top of the plane. to a mass of 4 kilograms which is hanging freely. With the string taut, this taut means tight, the system is released from rest. Part A, find Roman 1 the acceleration of the system, and Roman 2 the tension in the string. Then part B, determine Roman 1 the velocity with which the 4 kilogram mass hits the ground, and Roman 2 the time the 4 kilogram mass takes to hit the ground. So still in this case, they have not given us a sketch, so what we are supposed to do, we have to read the question, understand it, and then first draw a sketch. So mechanics, it is easily done when you draw a sketch. So they told us that the slope is 1 meter long and 6 meters long and 1 meter high, meaning that 6 will be the hypotenuse and 1 will be the opposite. Therefore sin theta will be equal to 1 over 6, implying that theta is 9.5940 degrees. So with that we can make our sketch of the information given. So that is the information. Next is to show the forces acting. So we shall begin with the weight, which is 2g, and with this 2g will be resolved part of the plane to give you 12g. So 12g sine 9.594, and resolved also perpendicular to the plane to give you 12g cos 9.594. The normal reaction will be R, and tension here will be upwards up the plane, which is T. Here it will be down the plane, which is also T. Here the weight will be for G, and here tension will be upwards and it will be T. Here downwards and it will be T. So next is that to show which move downwards. So this will move downwards and this will move upwards. So now that we have drawn the correct force diagram, we shall answer the question. So for the 12 kilogram mass, we shall be interested in this and this acceleration. So it is moving upward the plane, meaning this resultant force will be T minus 12g sine 9.594. So we shall come and write that being equal to MA, where M is 12. So when I simplify, this is the same as 1 over 6, therefore I'll come up with T minus 19.6 equal to 12A. That is equation 1. So now we shall go to the 4 kilogram mass. So for the 4 kilogram mass, we are interested in this part. Therefore, it will be 4G, resultant force will be 4G minus T equal to 4A. Substitute for G, I'll come up with 39.2 minus T equal to 4A. So that will be equation 2. So I have 2 equations and 2 unknowns. So what I'm going to do, I'm going to add the 2 equations. When I add the 2 equations, I come up with that, because this T and this T cancels, then this and this gives me positive 19.6, then this plus this will give me 16A. Therefore A will be equal to 1.225 meters per second squared. So before we go to the next slide, let's see how mass can be awarded for this slide. So B1 for the correct force diagram, M1 for resolving. So resolving is mobile, can be given at that step or at that step. Then B1 for equation 1, B1 for equation 2, and B1 for addition, and A1 for output. So remember, part Roman 1 they wanted acceleration, so that's what we have got. Roman 2 they want tension in the string, and part B part B Roman 1 they want velocity with which the 4 kilogram mass hits the ground, and Roman 2 they want the time the 4 kilogram mass takes to hit the ground. So that has been Roman 1. Now let's go to Roman 2. So from equation 1, we shall come and substitute for A to come up with T being equal to 34.3 newtons. Then part B, Roman 1, the distance is 1 meter, initial velocity is 0 because it was at rest, acceleration you have got it. Therefore, you can come and say that v squared is equal to u squared plus 2as. Therefore, velocity will be equal to u, which is 0, a is this, and s is that. Therefore, velocity is 1.5652 meters per second. Then for Roman 2, they wanted time, so we shall use the first equation of motion. So v minus u is equal to a. So v is that, u is that, and a is that. Therefore, the time will be 1.277 seconds. Basically, that's what they wanted, and now let's see how mass can be awarded. So this for tension, substitution, and output. Here also substitution and output. Here also substitution and output. So that was question 2. Now we shall go to question 3. Question 3 says, came from UNEB 2003, paper 2, question 11, and it says, blocks A and B of mass 2 and 3 kilograms respectively. So respectively means A is 2 and B is 3. Are connected by a light inextensible string passing over a smooth pulley as shown below. So in this case, they have helped us by drawing for us the sketch. So this is A, which is 2 kilograms, and this is B, which is 3 kilograms. So block A is resting on a rough plane inclined at 30 degrees to the horizontal, while block B hangs freely. When the system is released from rest, block B travels a distance of 0.75 meters before it attains a speed of 2.25 meters per second. Calculate Roman 1, the acceleration of the blocks, Roman 2, the coefficient of friction between the plane and the block A, and Roman 3, the reaction of the pulley on the string. So the first thing to do is to redraw the given diagram, first diagram, the given diagram, and we show the forces acting. So first of all, you know that acceleration is equal to now that is third equation of motion, because we shall need acceleration in our sketch. So third equation of motion, acceleration is equal to v squared minus u squared over 2s. Therefore, when I substitute for v, substitute for u, substitute for s, I come up with acceleration being equal to 3.375 meters per second squared. So that was Roman 1. Now Roman 2, we need a sketch. So next is to show the forces acting. We shall begin with the weight, which is 2g acting vertically downwards. So component of its weight parallel to the plane will be 2g sine 30, and perpendicular to the plane to be 2g cos 30. The normal reaction will be capital R. The tension here will be up the plane, here to be down the plane. Then here weight will be 3g, and here tension will be upwards, here to be downwards. Then the acceleration, this one moves downwards and this one moves upwards. Okay, so basically that's the sketch. So because this one is moving upwards and it is rough, the plane is rough, friction will act downwards. So before we go to the next slide, let's see how mass can be awarded for this slide. So M1 for substitution, A1 for output, and B1 for the correct force diagram drawn using a ruler. So next we shall resolve vertically for the 3 kilogram mass. So for the 3 kilogram mass, for this 3 kilogram mass, we are interested in these forces. We are interested in this. So resultant force will be downwards, which is 3g minus t equal to 3 times a. So a is this. So you come and write that equation. So that means that T is the only unknown, therefore T will be equal to 19.275 newtons. What about resolving perpendicular to the plane for the 2 kilogram mass? So perpendicular to the plane, this is what we are going to get. So perpendicular to the plane, we are interested in this. We are interested in that. So that means that R is equal to 2g cos 30 degrees. So we shall come here and say that R is equal to 2g cos 30 degrees. When I substitute, I come up with R being equal to 16.9741 newtons. Then next is to resolve parallel to the plane. So parallel to the plane, this is what we are interested in. So parallel, we are interested in these forces and also this acceleration. Therefore, it is up the plane, meaning it is one force will be T minus the sum of this 2g sine 30 plus mu R equal to ma, where A is that. So you come and write that T minus open brackets 2g sine 30 degrees plus mu R is equal to A. So the good thing, we know A and we know R, which is there, and we know G and we know T. So that means we can get the mu, which is unknown. So when I simplify, I come up with that and simplify further, then make mu the subject to come up with mu equal to 0.1605. So before we go to the next slide, let's see how much can be awarded for this slide. So M1 for substitution and A1 for the tension, B1 for getting normal reaction, M1 for resolving, and M1 for substituting, A1 for output. So that is Roman 2. Now Roman 3, they wanted the reaction of the pulley on the string. So the first thing to do is to make a sketch. So we shall extract out the forces on the pulley. So if you look at this pulley, if you go back to this sketch, the tensions on the pulley are these ones. So because of these two, there will be a reaction in that direction. And this angle is 30, meaning this is 60. And because this is 60 and these are two equal forces, it means that they will be divided into two to give you 30 here and 30 here. So that is why in our sketch, in this sketch, you are seeing 30 here and 30 here because the whole of it was 60, but because these two forces are the same, there will be, this angle will be divided into two. So this is the reaction of the pulley which they want. So what we shall do, we are going to resolve along this line. Now when we are resolving, we are going to resolve along this line. So when you are resolving, where the angle lies becomes cos. What does that mean? It means that the resolved part of this tension along this line will be T cos 30 degrees, and also for this along this line will be T cos 30 degrees. So what does that mean? It means that the RP will be equal to 2T cos 30 degrees because you add these two resolved components. So I know the value of T, so when I substitute, I come up with RP being equal to 33.8353 newtons. Therefore, the reaction of the pulley on the string is 33.3853 newtons inclined at 30 degrees to the vertical. So B1 will be for the correct force diagram, M1 for substitution, so reaction for substitution, and A1 for the reaction, and the direction must also be seen. So now we shall go to question 4. So question 4 says a particle of mass 4 kilograms in contact with a smooth plane of 5 in 6, note that word 5 in 6, is connected by a light inelastic string passing over a smooth light fixed pulley at the top of the plane and under a light movable pulley carrying a mass of 14 kilograms. The other end of the string is fixed to a point above the fixed pulley. If the parts of the string supporting the movable pulley are parallel and the system is released from rest, find Roman 1 the tension in the string and Roman 2 the acceleration of the 14 kilogram mass. So in this case they have not drawn for us a sketch, so the first thing to do is to read the question, understand it, and then make a sketch. So we know that slope of 5 in 6 means sin theta is equal to 5 over 6. That therefore theta will be 56.4427 degrees. Therefore we shall come and make our sketch of the given information. So that is the given information. Next is to show the forces. So we shall begin with this weight, which is 4g, acting vertically downwards. Then we resolve it parallel to the plane to give you 4g sine this angle. Then resolve perpendicular to the plane to give you 4g cos that angle. The normal reaction will be capital R. Tension here will be up the plane, here tension will be down the plane. Then for this pulley, weight will be downwards and it's 14 kilograms, so it will be 14g. Then tension will be upwards here and it will be downwards here. This side it will be upwards here and downwards here. So this pulley will move downwards because it is heavier than this, and this will move upwards. Now, like we already saw under pulley systems, if this acceleration is a, this acceleration will be 2a. So the acceleration of this particle will be twice the acceleration of this movable pulley if there are 2 strings here. So now we shall go to Roman 1. So if you missed out, you can go back to the playlist and find those videos. They are already there under pulley systems. So for the 4 kilogram mass, we shall be interested in this and also this. Therefore it is moving upwards, meaning T will be, the resultant force will be T minus 4g sine that angle. Therefore we shall come and say T minus sine 4g sine that angle is equal to 4a. So that our acceleration is 2a. That is why you see here mass times acceleration. So when I simplify, I'll come up with T being equal to, so I'll come up with an equation with 3t minus 98 equal to 24, and that is equation 1. What about the 14 kilogram mass? So for the 14 kilogram mass, we are interested in these forces. We are interested in those forces. Therefore, it is moving downwards, meaning the resultant force will be 4g minus 2t. So you come and say 4g minus 2t is equal to 14a. Simplify, I'll come up with that. Therefore equation 2 is 68.6 minus t equal to 7a. So I have 2 equations and 2 unknowns, so I have to solve them simultaneously. So before we go to the next slide, let's see how mass can be awarded. So B1 for the cross force diagram drawn using a ruler, M1 for resolving, and small bar can be given at that step or this step. B1 for equation 1, B1 for equation 2. So first of all, they want us to get tension and also acceleration of the 14 kilogram mass. So let's solve them simultaneously. So when I say 3 times equation 2 plus equation 1, it will give me that. So this and this cancels, this minus this gives me that, and this gives me that. So that means that A is equal to 2.3956 meters per second squared. Then from equation 2, I'll come up with a substitute for A, therefore I'll come up with my value of T being equal to 51.8311 newtons. Therefore, for Roman 2, the acceleration of the 14 kilogram mass will be equal to A, which is that. So basically that's what they wanted. Now let's see how mass can be awarded. So M1 for this addition, A1 for acceleration, M1 for substitution, A1 for the tension. So this was already seen because this mark was already given here. So I believe by now you have marked yourself and checked your progress. So what I'm going to do, I'll leave you with another set of questions still on motion of connected particles involving inclined planes. So that brings us to the end of this video. Thank you for watching, and be reminded that the solutions for the assignment left will be available in the next video. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video with the solutions has been uploaded. Otherwise, thank you for watching, and also if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that we can all benefit as a family.